There is a small molecule circulating in your bloodstream right now that is keeping you alive, alert, and functioning. It is not oxygen. It is not protein. It is not fat. It is glucose. Glucose is a simple sugar with the chemical formula C6H12O6. Structurally, it is a 6-carbon molecule that forms a ring shape. Biochemically, it is one of the most important fuels in human physiology. Almost every cell in the body can use glucose to produce energy. Whenever you eat carbohydrates, whether it is rice, bread, fruit, lentils, pasta, or sweets, your digestive system breaks them down into smaller units. Eventually, most digestible carbohydrates become glucose. That glucose then enters your bloodstream. Your bloodstream, however, is not designed to hold large amounts of sugar. In a healthy individual, the amount of glucose circulating at any moment is roughly about 1 teaspoon, approximately 4 grams. That is a very small quantity, and the body regulates it carefully. When you eat a meal, especially one rich in refined carbohydrates or added sugars, blood glucose levels rise. This rise is completely natural. In response, the pancreas releases insulin. Insulin acts like a signaling hormone. It helps move glucose from the bloodstream into cells, where it can be used immediately for energy or stored for later. First, glucose is stored in muscles and the liver in the form of glycogen. These are short-term energy reserves. If glycogen stores are already full and excess glucose continues to circulate, the body can convert some of that excess into fat for long-term storage. This is a normal metabolic pathway. Glucose itself is not harmful. It is essential. The brain relies heavily on glucose as a primary fuel source. Red blood cells use glucose almost exclusively. During exercise, working muscles rapidly consume glucose for energy. Without it, the body cannot sustain basic biological processes. The key factor is not the presence of glucose, but the pattern of how it rises and falls in the bloodstream. After a rapid rise, blood glucose levels typically fall as insulin helps move sugar into cells. When the rise is steep, the drop can sometimes feel noticeable, such as fatigue, hunger, or reduced focus. These sensations are common physiological responses. Over long periods of time, consistently elevated blood glucose levels may be associated in research with metabolic conditions such as type 2 diabetes and cardiovascular disease. These outcomes depend on many interacting factors, including overall diet, physical activity, genetics, stress, sleep, and existing health conditions. That is why modern nutrition discussions often focus on blood sugar stability rather than eliminating carbohydrates entirely. Balanced meals that include fiber, protein, and healthy fats tend to slow digestion and lead to a steadier release of glucose into the bloodstream. For example, eating vegetables or a salad before a carbohydrate-rich portion can slow absorption. Pairing rice with lentils, yogurt, or vegetables changes how quickly glucose enters circulation. Even a short 10-minute walk after a meal helps muscles use circulating glucose more efficiently. None of these strategies require extreme restriction. They are adjustments in timing, pairing, and overall dietary pattern. It is also important to recognize that individual responses to carbohydrates can vary. Age, body composition, activity level, and metabolic health all influence how the body handles glucose. What causes a sharp rise for one person may produce a milder response in another. At its core, glucose is neither an enemy nor a miracle. It is a molecule, a fuel source, tightly managed by a sophisticated hormonal system. The human body has evolved complex mechanisms to maintain balance. Understanding glucose is not about fear. It is about awareness. When we understand how food becomes energy, how insulin responds, and how balance is maintained, we gain clarity over our daily choices. Right now, in your bloodstream, only about 1 teaspoon of glucose is circulating. Carefully regulated, constantly monitored by your body. That tiny molecule powers your thoughts, your movements, your heartbeat. Small in size, fundamental in impact.